Good morning, children. This is ninth Physics, Chapter 8, Motion. Topic 7, Acceleration and Uniform Circular Motion. So let's go with the learning objective first, children. So in this class, we are going to know what is acceleration. We will know the SI unit of acceleration. We will be able to define what is positive acceleration, negative acceleration, and zero acceleration, right? And then we will know what do we mean by uniform acceleration and non-uniform acceleration, right, children? And then, children, we are going to study about uniform circular motion. And after that, we are going to derive a formula for speed, for calculating speed in a uniform circular motion. Right, children? So let's start with the term acceleration. So, children, you might have heard the word accelerate. You might have heard the word to accelerate. Okay, accelerator. In cars, we have accelerator, right? So you might have seen your parents while they drive the car, they use accelerator. So as they press accelerator, the speed of the car increases. So here also the same thing we are going to apply, that on pressing the accelerator of the car, the speed of the car, the velocity of the car, it changes. There is change in velocity of the car, right, children? So the same thing is over here, that how fast the velocity is changing. How fast the velocity is changing. So we are comparing the change in velocity. We are taking it with respect to time. Okay, so rate, how fast, right? How fast there is change in the velocity. So that is exactly what your acceleration is. So children, acceleration is defined as the rate of change of velocity, means at what rate the velocity is changing, right? So we know the rate is with respect to time. So either you can define it as this, that is the rate of change of velocity, or you can define acceleration as change in velocity of object per unit time. So that is with respect to time. Yes, children. So we can write down the formula of acceleration, and that is acceleration equals to change in velocity upon time taken. Yes, what's the change in velocity and what time was taken for that change in velocity? Clear? So I hope we are clear with the definition, that at what rate there is change in velocity, that will give you your acceleration, right, children? Now let's proceed towards the SI unit of acceleration. Let's proceed to the SI unit of acceleration. Now, as we know, acceleration is change in velocity, right, children? So change in velocity is final velocity v minus initial velocity will give you change in velocity, right? Change in velocity क्या होता है बेटा? Final velocity minus initial velocity. So it is v minus u by t, right? Acceleration is what? A equals to change in velocity. A is change in velocity upon time, right? Upon time taken. Change in velocity is what? Final velocity minus initial velocity upon time. So final velocity is v, initial velocity is u, upon time is your acceleration. Now we know the unit of velocity, that is meter per second, and unit of time is second. So your second will be multiplied and you will have in the denominator second square. So your SI unit of acceleration is meter per second square, or you can also write it in the terms, that is m s raised to minus 2. Okay, children. So the SI unit of acceleration is meter per second square. And as you can see, acceleration is what? Change in velocity, right, upon time. So velocity is a vector quantity. So similarly, your acceleration is also a vector quantity. Your acceleration is also a vector quantity. And beta, its direction is taken along the direction of change in velocity. Okay, just direction of velocity change हुई है, that would be the direction of your acceleration. So let's see, here we are having few things, but these things we will cover it on the next page, so I am not explaining you this. Just a second, children. Okay, here it is. This is very, very important, children. Now, acceleration can be classified into three categories, right, children? First is positive acceleration, second is negative acceleration, and the third one is zero acceleration. Positive acceleration, let's start with that. Suppose children, a train, a train is standing at the station. Now the train starts. So initial velocity of the train when the train was standing at the station, u was 0. Initial velocity was 0. And when the train started, suppose the velocity of the train is 30 kilometers per hour. So if we calculate the acceleration, then a will be equals to 30 minus 0 upon time, whatever time it is, right, children? A will be 30 minus 0 upon time. So here the value of A is positive, right, children? So when the final velocity is greater than the initial velocity, so when the final velocity is greater than the initial velocity, then the object is said to be under positive acceleration. Example, a train starting from a station. Right, children? Final velocity is greater than initial velocity. So its acceleration is positive acceleration. Next is, children, negative acceleration. So quite similar to positive acceleration, only one change over here. That is, here we will take the example of a train which is approaching towards a railway station. Right. Now, as the train is approaching towards the station, slowly, the velocity of the train will become 0. When the train is going to reach the station, it's going to stop there. So, its velocity will become 0. So, here the final velocity, children, here the final velocity is 0. And initial velocity, it was moving with some initial velocity, suppose 60 kilometers per hour. So finally, as the station came, the driver applied brakes and the final velocity became 0. So here, children, the initial velocity is greater than this, right? So if we find out the value of acceleration, A equals to V minus U, 0 minus 60 upon T. So beta 0 minus 60 upon T, so value of A will be negative, na? Value of A will be 60 by whatever time it is given to us. So answer of A is negative. So this is the case for your negative acceleration. That is, if the initial velocity is greater than the final velocity, then the object is said to have negative acceleration. And your example is a train stopping at a station. Yes, children? Okay, chalo. Let's proceed further to the zero acceleration. Zero acceleration. So zero acceleration, when you will say, beta, when your, we know A is what? V minus U by T. Now if V and U are same, if A is V minus U by T, if I say V and U are same, then suppose V is also 30 kilometers per hour, U is also 30 kilometers per hour. So 30 minus 30 is 0. Means when, okay, you can have an example. Suppose a car is moving with a constant velocity of 30 kilometers per hour. A car hai, it is moving constantly with a velocity of 30 kilometers per hour. So initial velocity is also 30. Final velocity is also 30. So the acceleration of the car is 0. Right, children? So if the initial velocity is equal to the final velocity, the object is said to have 0 acceleration. Right, children? An example, that is a car moving with uniform or constant acceleration, constant velocity. Sorry, है ना? Constant velocity. Fine, children? Sure. Now next, let's proceed to the two types of accelerations are classified into two types: uniform acceleration and non-uniform acceleration. Right? We are very much familiar with the word uniform now, right? So it is equal in equal time, right? Now in acceleration, what is going to be equal? Now we know the definition of acceleration. Acceleration is change in velocity upon time. So in for uniform, this change in velocity has to be equal in equal interval of time, है ना बेटा? So change can be positive, it can be negative, right? Change can be, it can be increase, it can be decrease. हो सकता है you are increasing the velocity or you are decreasing. Change can be in both the terms. An object has to move in straight line because it's velocity, है ना बेटा? So the change in velocity is equal in equal interval of time, then the object is said to have uniform acceleration. So the same definition I'm reading for you, that is object is moving on a straight line first thing, and velocity increases or decreases. For this we can use the word that the change in velocity is equal, or instead of writing increases or decreases, you can go for the word change in velocity is equal in equal interval of time, then the acceleration of the object is said to be uniform. Okay, so how we are going to define uniform acceleration? If a body is moving on a straight path, first thing, and its change in velocity is equal in equal interval of time, then its acceleration is uniform. Here we are having an example for that. For example, suppose here you are standing on a multi-story building, right? And you are having a ball in your hand and you are going to drop the ball on the ground. So as initially the ball was in your hand, the initial velocity of the ball is 0. And here the ball is going to move in a straight path, right children? The direction is not going to change. Now, after every second, you are going to note down its velocity. After every second, you are noting it down. So you saw that at the end of 1 second, its velocity was 9.8 meter per second. At the end of 2 seconds, its velocity was 19.6. At the end of third second, its velocity came out to be 29.4 meter per second. After 4 seconds, you found the velocity to be 39.2 meter per second. And finally, after 5 seconds, the velocity was 49 kilometer per second. Right. Now let's see what is the change in the velocity. Let's see what is the change in the velocity. So here velocity changes 9.8 minus 0, that is 9.8. Next velocity change, in दोनों में how much velocity change, how much increase in velocity? 19.6 minus 9.8, that is 9.8 meter per second velocity change हुई है. So यहाँ पे भी change was 9.8, here also changes 9.8. So you will see children that the change after every second is equal, that is 9.8. So the change in velocity is equal in equal interval of time. So this is an example for uniform acceleration. Right children? Next is non-uniform acceleration. Non-uniform acceleration, the change in velocity is unequal, right? Whatever the velocity is changing, that is not equal, that is unequal. So object is moving on a straight path and its velocity changes by unequal amount in equal interval of time, then the body is said to be in non-uniform acceleration. So children, now this is an example for non-uniform acceleration. Suppose your car is traveling on an crowded place, right? It is a crowded marketplace where the car is traveling. So let's see. Right now, this is the origin, right? After 1 second, the velocity of the car is 30 meter per second, right? After 2 seconds, its velocity is 20 meter per second. After 3 seconds, oh God, the car accelerated. Might be it has reached the highway. No? Its velocity is 60 meter per second. And after 4 seconds, it is 50 meter per second. Instead of taking car, we can take any object, any small object, right? So here if you see the change in velocity, here the velocity is changing by 30 minus 0, that is 30 meter per second. Here the change in this interval of time, that is in the second, in this slot, in second slot, the change in velocity is 20 minus 30, right? That is minus 10. Here in the next slot, the change in velocity is 60 minus 20, 40 meter per second. And finally, if you see the change in velocity is children 50 minus 60, that is minus 10. So here you can see that the change in velocity, it might be beta increasing, it might be decrease in velocity, that does not make any difference. But the change in velocity is not equal. For the first time slot, it is 30, then it is minus 10, then it is 40, then again it is minus 10, but it is not equal, right? So as it is not equal, the change in velocity is not equal. So if an object is moving on a straight path and the change in velocity is unequal in equal interval of time, the motion, the acceleration is said to be non-uniform acceleration. Now, yes, now let's move to the last topic of today, that is uniform circular motion. So uniform circular motion. So word uniform means its speed is uniform, its speed is constant. Circular, the object is traveling on a circular path. So this gives you the definition for the uniform circular motion. That is, when an object moves on a circular path with uniform speed, its motion is uniform circular motion. So object is moving on a circular path with uniform speed. Then its motion is said to be circular, uniform circular motion. Right, children? So let's little bit we will zoom on the uniform circular motion, and that is this part. Okay, now it's visible. Now, children, here the object is moving on a circular path. You can assume that you have tied a stone to a string and you are just rotating it, right? You are just moving the stone in a circular path. We have done, right, children? So here the body is moving on circular path and its velocity is not constant, but its speed is constant, because we know, children, velocity is speed plus direction. है ना? Velocity is speed plus direction. Now here beta speed is uniform, speed is constant, but direction is not constant, because on a circle, when an object is moving on a circular path, at each and every point the direction of the motion is changing. At this point its direction will be along this, but as it is hold it from the center, it is turning, and the direction is constantly changing. And if you want to find out the direction at a point, suppose you want to find out the direction of the stone at this point, then what you will do, you will just draw a tangent. So this tangent gives you the direction of the object at this point, right? So in circular motion, The direction is changing, so velocity is changing. It means, है ना बेटा, velocity is not constant. Speed constant है, that is in your hand. If you are moving with uniform speed, then find the speed is uniform. But velocity can never be uniform for uniform circular motion, because at each and every point the direction is changing. So children, okay, now we know beta speed equals to distance by time. Yes, we know. Now on a circular path, what is the distance? Distance covered, the total distance covered when you complete one circle. That is how much? Circumference of circle. That is 2 pi r, and we know r is the radius of the circle. Right, children? So if we put the value of distance, that is 2 pi r. If we put the value of distance 2 pi r, speed equals to distance 2 pi r upon time. So this is your formula for speed when the object is moving in uniform circular motion. Right, children? Now, let's see the accelerated motion. Accelerated motion. So here we saw that the speed is constant. है ना बेटा? We saw that the speed was constant, but direction is changing as it is moving on a circular path. So your circular motion is considered as accelerated motion. आपको क्वेश्चन आ सकता है that circular motion is option A, accelerated, non-accelerated. Options would come like this. It is accelerated. Why it is accelerated? आप बोलोगे मैम स्पीड कहाँ चेंज हो रही है? But children, accelerated means change in velocity. Speed is not changing, but direction is changing, right? So as there is change in direction, it is accelerated motion. Okay, children. So this is the difference between uniform linear motion and uniform circular motion. In linear motion, the body is moving on straight line, and circular motion, it is moving on circular path. Linear motion, acceleration is 0, right? As velocity is constant, because speed is also constant and object is moving on straight path, direction is also not changing. So acceleration 0 hoga for uniform linear motion. But uniform circular motion, it is an accelerated motion, because at each and every point of its motion the direction is changing, and as there is change in direction, its velocity is changing. Okay, children, so this is it with today's class. So I hope we are clear with the acceleration. Right, children? Okay, children, bye bye, take care.